Welcome to my session on Spatial Analytics with Base SAS, examining contributions to OpenStreetMap for the COVID-19 response. My name's Michael Matthews. I have more than 30 years of SAS experience, with my first job being with SAS Institute in Australia, where I worked in the technical support, consulting and education areas. I believe the phrase lifelong learner is becoming more popular these days, and one thing I believe is in actually sharing what I learn and helping others. One of my many interests is open data and maps. If we look at the agenda for this session, I'm going to introduce you to OpenStreetMap, the data behind OpenStreetMap, and then look at mapping those objects with the base SAS procedure ProcSGMap. The second half of this presentation, I'll look into the Humanitarian OpenStreetMap team and look at the related projects in Peru assisting with the COVID-19 crisis. I will then examine the extra tags that have been added to OpenStreetMap, specifically for COVID-19, which have been added globally, but look in this case at the use of that in Italy. So let's start with, what is OpenStreetMap? I like to think of it as the Wikipedia of maps. The initial appearance is similar to what you see with many other mapping providers, however there are many differences. Some of the infrastructure you see has been included through bulk imports, such as the road network in countries where that's available with suitable open licenses. However, many other details are created by community contributions on top of this, providing a rich set of information across the globe. The standard view looks familiar to many of you. Roads, parks, infrastructure. Changing to the transport map layer shows an emphasis on public transportation, such as trains and buses. The roads and buildings are still there, however subdued as they are not the primary purpose of this layer. These different layers are represented using something called a tile server, which generates these images. The reason OpenStreetMap can generate all of these different visualizations is due to the database behind the scenes that contains all of the spatial information and metadata. It's possible for you to copy that database and then make use of it yourself. You could produce your own tile server, potentially put an API across it so that you could read the data and query it, or perform analytics directly on that database. The OpenStreetMap database is open data licensed under the Open Data Commons Open Database License by OpenStreetMap Foundation. I suggest you read the licensing, however the main request is to include attribution, which you'll see there at the bottom of every page in OpenStreetMap. Note that the database is used by many different organisations, including a recent article I read with the Lyft ride-sharing service. And of course you've probably seen the articles about Microsoft Flight Simulator using the OpenStreetMap as well. Now that you have an introduction to OpenStreetMap, let's think about the data behind it. Every road, intersection, many buildings, the rivers, the parks, the possibilities available with that data are endless from a spatial perspective. But before we look into the data in detail, I'll provide you with some of the terminology used in OpenStreetMap. These are the four base concepts that you need to understand for OpenStreetMap data. Nodes, which are the points that make up the objects in OpenStreetMap. Ways, which are an ordered collection of nodes. You can see the streets and also the buildings in this example are ways. Relations, which link ways and nodes together. For example, these two buildings highlighted might be part of a school. And finally, tags. This is the rich data that describes the nodes, ways and relations. You can see here the roads are named, including speed limits, yield signs. The buildings are also tagged, and in one instance there are further property details provided. So how can you get access to this rich data? There are APIs available for small volume extracts from OpenStreetMap, and also the various Overpass API instances. Global extracts are also available for download. If you select the entire planet, it's currently around 100 gigabytes compressed. There are also tile servers for imagery that we saw in the introduction. OpenStreetMap.org is available for personal use, and you can host your own for commercial. For example, SAS Institute have their own OpenStreetMap tile server for use with their SAS mapping products. With this understanding of OpenStreetMap and its data, I'm now going to look into a general example of mapping OpenStreetMap objects using base SAS before moving on to the humanitarian contributions to OpenStreetMap. This example will help you to understand the data and also consider how you could add your own business or customers onto a map using Base SAS. In this example, I'm going to use the Overpass API to extract data from OpenStreetMap. The text file I'm showing here supplies the specifications I'll pass to the API. You'll note that I'm looking in Carey for all buildings with a name containing the string SAS building. At this point, I need to emphasise that this presentation is an introduction to many concepts. I will not be giving in-depth explanations of the meaning of each line in the API calls, or even the SAS code which is following. My aim is to highlight the concepts, and if you want further details, then please refer to my paper or the GitHub repository, which I will reference at the end. It contains all of the source code used so you can reproduce these visualizations. I will use proc-HTTP to call the Overpass API to retrieve the results of the query. Firstly, I will create a file name pointing to the specifications from the previous slide, and then use that for the in equals option to proc-HTTP. Next, I'll create another file name for the response to the API, which will be created on my local disk. Passing the appropriate URL and executing this code will result in an output file looking like this. The header contains generic details, followed by all of the associated ways. You can see the center coordinates, the associated nodes around this way, and also the metadata tags, including the type of building, its name, and the fact it is non-smoking and that it has wheelchair access. This is an amazing level of user-contributed details. Now that we have the XML data, how can we import it and plot it in SAS? The XML v2 libname engine and an appropriate XML map can provide the mapping between an XML file and SAS to make it appear like any other libname. In this case, you can see the tables automatically created to make it easy for you to read this file. The XML map used here is included in the GitHub repository I will include at the end of this presentation for any of you to use with OpenStreetMap data. Using a data step, I can merge these details together to find all of the SAS buildings and their geographical coordinates, which you can see in this display. Now that we have the data, how can we display it on a map? Base SAS includes proc-SGMap. You will note the OpenStreetMap statement. This tells SAS to use their OpenStreetMap tile server for the background imagery. You can see the attribution is automatically included. A scatter statement in proc-SGMap then plots the various buildings on the map using the coordinates you saw on the previous slide. It is also possible to label the points by using the data label options. As you can see, the SAS building names are now included. Remember, this data is publicly available in OpenStreetMap. Any of you can run this same code. You could potentially find your business or customers using a similar technique. While a shopping mall is a single building, often the various shops themselves are represented as nodes within that, with the appropriate tags included. And if your business is missing, you can add it to OpenStreetMap so that it's available and up to date for everyone. To show the rich set of data available in OpenStreetMap, I'm now going to quickly add the sculptures that are present on the SAS campus. This new query to the Overpass API looks for nodes where the key tourism is set to artwork. You'll notice that I changed the request from Carey to a specific set of coordinates for the bounding box. My first attempt at this returned public sculptures in Carey, Northern Ireland as well, which was not quite what I was looking for. I could have asked for Carey as a subset of North Carolina, but that is actually a complex geographical calculation and can time out with the API. I'll show alternative methods of extracting this data later in the presentation. The resulting data includes ways and now also the nodes with the sculptures along with their tags. In this example, you can see I'm reading more tables from the libname created by the XML map. In this situation, I know the nodes, or points, are the sculptures, and the ways are the buildings. Bringing this data together enables me to have the coordinates for all objects, and you can see the name of one of the sculptures. The others have been located, however the name is currently missing. Anyone who visits the SAS campus is free to add these details to OpenStreetMap, and maybe the next time I run this query there'll be additional details. I can now use the scatter statement again to produce the desired results, showing the buildings and the location of the sculptures on the SAS campus. The group option controls the variable to use to distinguish the different values, and the name option allows control over the key legend. Note that if you're wondering about the colours, I'm using proc template to control those, which you can see in my GitHub repository. Also note that you need SAS 9.4 M6 at least to be able to run these examples. Before I finish with these generic examples and move on to the humanitarian work done in OpenStreetMap, I'd like to show another method of representing ways in SAS. In this example, I read from Manhattan, the way named Central Park, to collect the details of the outline itself rather than just the centre. In this use of ProcSGMap, I'm using Esri as the background imagery. You can see Esri also uses OpenStreetMap as part of its data sources and therefore also includes the attribution. Finally, I'm using a series statement to draw the lines of the way rather than scatter, which just plots the individual points. I hope these examples have shown you how you might be able to use OpenStreetMap and SAS to add your business to the map. I will now look at the humanitarian uses for OpenStreetMap. My first exposure to the humanitarian OpenStreetMap team was in 2018 with the Ebola outbreak in the Democratic Republic of the Congo. We're all familiar now with the concept of contact tracing. However, the maps you and I take for granted do not exist across the entire planet. I didn't have to travel to Africa to volunteer. Instead, I joined people from across the globe to add communities like this one to the map. It is thanks to Bing, Esri, Mapbox and others who provide their satellite imagery for free so that volunteers can trace the details into OpenStreetMap and add these communities and infrastructure to the map. This enables aid workers, local governments and of course the residents themselves to have useful and reliable maps for many different purposes. This map presents what would have been presented to an aid worker in the past. Now, with OpenStreetMap, this region has been extensively mapped. You can see the individual communities named along the roads, hospitals, police stations, churches. Changing to the humanitarian layer, you can also see items that would not be present in other mapping solutions, such as the water points where residents can find fresh water supplies. A summary of the process is as follows. Remote mappers add features by tracing satellite imagery into OpenStreetMap. Local mappers add the details, identifying hospitals, schools and other important infrastructure. And the maps and data are then available for everyone, including aid organisations. Requesting organisations to HotOSM include the Red Cross, Medicine Sans Frontiers, USAID, local governments, and the list goes on. Some of you might be wondering why there is a need for manual tracing of roads and buildings with the advancements in AI and computer vision. This is becoming part of the solution, however the manual contributions of the global volunteers is still critical and in some cases provides training data for future AI-based solutions, and also volunteers can validate the output. The list of HotOSM projects covers the globe, however is concentrated in certain regions based on requests to assist with humanitarian crises. The SGMap output here shows the locations of projects across the globe. I've highlighted the projects related to the original Ebola projects I worked on, and you can also see where specific project requests have been entered for COVID-19 assistance, in addition to the frequent humanitarian requests that continue to this day. In the following case study, I'm going to look at some of the requests in Peru. Machu Picchu in Peru has been on my list for travels for many years. I haven't made it there yet. Due to the COVID-19 situation and the lack of tourism supporting the local population, the regional government made requests to help complete the maps in this area. This was to help identify and provide cash transfers to families impacted by the quarantine and state of emergency declared in the region, and also for longer-term regional planning. My goal in this example is to see the number of new buildings that were added to the map during these projects. In previous examples, I used Overpass API to extract small volumes of data. For larger volumes, there are PlanetOSM extracts available. These include the entire planet, around 100 GB compressed, and also separate extracts at a country level. Some countries also include state-level extracts. Once you have this data, there are many tools available to work with the data to extract what you need. In this case, I'm using Osmosis, which is a command line tool, to read the latest Peru extract, selecting a bounding box for the region of interest, looking for buildings, and writing the results to an XML file. Note that a file with an OSM extension is often just an XML file. The XML file output from Osmosis is in the same format as that returned from the Overpass API. As a result, I can use the same XML map to read the data. In this case, I need both the ways that identify the building and also the related nodes themselves using the wayNodes bridge table. This allows me to calculate the average of the node coordinates to come up with an approximate centroid. Looking at the data created, you can see we have the building type. Yes is the default when a remote mapper adds the details from satellite imagery, as they cannot know the purpose of a building. It is then the local mapper who would have identified this as a church. You will also notice the version here. Maps are always fluid, details always change. If a building is extended, moved slightly, or updated with additional tags, the version is incremented. These older IDs have had a number of changes, however newer ones will often be version equals 1. Now that we have all the buildings in the local area, let's use ProcSGMap again. I've selected to use the Esri topographical map, which shows the mountainous terrain in the area. You can see Machu Picchu in the top left and the regional centre in the middle. Using a scatter plot for this data shows a vast number of buildings across the map area. The data extracted from Osmosis included more than 334,000 buildings in the region. Notice that the buildings all merge together in densely populated regions. It's difficult to know if a blue pixel is one building or 10,000 buildings packed together in the same area. My paper and the GitHub repository show how to create a visualization like this, which provides a better representation of densely plotted details, where you can see the darker colour represents more than 2,000 buildings in that hexagon. The extent of buildings in this region is remarkable. This does not come from any automated source and is purely the work of dedicated volunteers across the globe who completed the various projects. It was interesting watching how quickly these projects were completed, I think due to people having additional time to work on them during the various lockdowns across the globe. To examine the contributions themselves, this data step is now selecting buildings modified prior to February 2020 as old or original, those after that date with a version equals 1 as recent, and the remainder is updated. Note that this could include recent buildings that were updated, however that level of analysis is outside the scope of this particular demonstration. Plotting with the appropriate colours, you can see dark blue are the buildings that have existed since before these projects were created, the lighter blue are the modified buildings, and the green are those that were added since the project started. The remote regional inclusion is impressive, and based on the project requirements, these people would have greatly benefited from the mapping provided by the global volunteers. The next case study is to look into the new tags created in OpenStreetMap to support the COVID-19 pandemic. You have already seen buildings and artwork tags. There are tags for roads, waterways, and many other useful features. Since the start of the COVID-19 pandemic, there have been a number of new tags created to help support the global requirements for support during this period. My goal in this example is to examine some of the new COVID-19 related tags and their usage. In this case, using Italy as an example, where the new tags have been used both for access through OpenStreetMap itself and also custom apps developed that use OpenStreetMap data as their base. Once again, I'm using the Planet OSM extract for Italy this time. I'm extracting the ways and the nodes, looking for COVID-19 related tags such as modified opening hours, if delivery is available, takeaway, etc. Note that I'm reading both the ways, which would represent a building, and also the nodes. Remembering nodes can be placed on top of a building, for example where one building supports multiple businesses. Using the same XML map, the data can be read into SAS. A quick histogram shows which tags are most frequently used in Italy. Remember, these tags are available globally, so some of them may have more frequent use in other countries. Using ProcSGMap, I can produce a quick scatter plot of where the tags have been used geographically. You can see the use has been concentrated mainly in certain cities, including Naples, Rome, Bologna, Milan and Venice. Bologna was one of the cities where the local government was encouraging the use of the new OpenStreetMap COVID-19 related tags. Using the same code, however adding a where clause on the coordinates around the area of interest, produces the following map. You can see that a number of businesses in this region have added the COVID-19 related opening hours and delivery information to their details on the OpenStreetMap database. This is then available for everyone within that region, for use both in the OpenStreetMap interface, but also in customised apps and reports. This is the end of my presentation. In conclusion, you can now see that SAS software can produce maps with OpenStreetMap and Esri backgrounds. OpenStreetMap is a rich source of data available for many purposes which can be used with ProcSGMap. OpenStreetMap and the humanitarian OpenStreetMap team support projects for a variety of global requirements, including the COVID-19 pandemic. If you'd like further details, there is SAS documentation online for ProcSGMap. Here is my GitHub repository, which has all of the code and examples used in this presentation, and you can also look at my paper. If you're interested in further details about OpenStreetMap, please go to openstreetmap.org, hotosm.org for the humanitarian OpenStreetMap, and missingmaps.org will also give you further details, including how to get involved in mapathons. Thank you. I hope you enjoyed this presentation.